everyone. Welcome to Avalue's webinar. My name is Huang. I'm the Senior Manager in charge of Avalue's DMS, Design and Manufacturing Service Division. Today, I'm glad to be here to present Avalue's Medical Design Manufacturing Service to all of you. Avalue was established in the year 2000. From 2001, we kicked off our first ever ODM project. Till now, we have executed for more than 300 ODM projects. 50 plus are medical-related products. And we have a lot of different design experience in different platforms, like AMD, Intel, NVIDIA, etc. And one of our customized medical products still in mass production and has been shipping for more than 14 years. And we are planning to produce this product for 2 more years before we close this project. At Avalue, we have solid product lifecycle management, capability, and experience. Here is the agenda for this presentation. The first one is project management. Second one is our design capability and the quality tools we use for our design team. The third one is our design quality validation overview. And the last one is our manufacturing capability and the quality tool. In the past 20 years, we have accumulated lots of successful cases. And here are some of the successful stories in the medical field. The first one is hemodialysis machine. The second one is display for retinal imaging device. The third one is ultrasound equipment, followed by the blood gas analyzer. And the last one is image-guided therapy system. For the image-guided therapy system, we provide 19-inch 4U level 10 fully integrated server to our customer. And this solution is to perform heart surgery in the operation room. This requires extremely high quality and high reliability product. This is an overview on the IQ2 PMI process. Once we receive customers' requirement and specification, and also their user behavior information, we will analyze the current solution and what is the challenge for the current one, and come out the new solution suggestion, and followed by the draft specification proposal to our customer. And we will do the system, hardware, software, and mechanical feasibility study. And at Avalue, we have a dedicated ODM task force, including the project management team, electronic engineer, bias engineer, and the mechanical engineering team. For the ODM service, we can provide the embedded board design, mechanical chassis design, firmware, API, and application development to the whole system design service to our customer. Specific new product introduction process. We have predefined development process and stages for both of the medical and non-medical projects. And there are 5 stages in our MPI process. The first one is pre-IBP phase. The second one is initial business plan phase, followed by the EBT, DBT, and the PPT stage. Our MPI process is based on Oracle Agile PLM system. And the Oracle Agile PLM system is also used by the worldwide top 10 EMS company as well. Central controlled PLM system. Here are the snapshots of our Oracle system. On the left-hand side, you can see our project with predefined phases. And in the middle, here shows the overall project progress and all of the documents uploaded to the system. On the right-hand side, you can see the project member assigned. And the system will send out an email to the team members to remind them of the activities or tasks to be due in the week. In-house design engineering team and capability. In our electronic engineering team, besides electronic engineer, we also have component engineer, layout engineer, power engineer, and also signal integrity, measurement, and analysis engineer. In our software engineering team, we have UEFI engineer for bias porting, IPMI engineer for server-grade IPMI and Redfish feature implementation, and also have OS and driver porting engineer and application development engineer. In our mechanical engineering team, we have industrial design capability. We have thermal design and evaluation engineer. And also we have dedicated packaging design engineer as well. The last one is our system design and integration engineering team. This is our product development flowchart. Our product design starts from the industrial design, followed by the key parts selection, and mechanical 3D and 2D design, all the way to functionality verification, signal power verification, and the design quality validation. During the whole design process, there are 4 checkpoints. When we finish the mechanical design, we will have thermal simulation and evaluation. When we finish the schematic design, we will have a schematic design review meeting. The design review meeting not only electronic engineer, we will also invite our software engineer and the EMC engineer to join the meeting to provide their comments. And before we release the Gerber file, we will also have the layout design review and also design for manufacturing and the DRC check meeting. Design consideration for medical grade equipment. Medical grade equipment has more stringent safety requirements compared to the ITE grade devices. For the ITE grade devices, it only requires 4 kV and 8 kV contact and air discharge ESD immunity. But for the medical grade devices, it requires up to 8 kV and 15 kV contact and air discharge ESD immunity. At Avalue, our medical grade product design starts from the right component selection, proper schematic and layout design consideration. And it is important to have all of the solutions on the board level instead of on the system level, because it can greatly to reduce the overall system cost. And we also have ESD chamber and the radiation emission test chamber to help our engineer to speed up their product development. Continue to improve our design quality. In our engineering team, we have complete design guidelines and design rules documents for our engineer to follow. We have unified the design formats to increase the design file readability and keep the design consistency. And that can help us to minimize the design changes from avoidable human errors and to improve the overall design quality. Design failure mode and effect and analysis. DFMEA is one of our quality tools we use for our medical grade products. We will list all of the functional requirements onto the design FEMA table and to investigate all of them if they have potential failure mode and what will be the potential effects of the failure. Do we have the proper mechanism to prevent the potential cause of failure from happening? If the risk priority number is too high, we will take further actions to minimize the potential causes, severity, and occurrence, and also increase the failure detection rate. Process failure mode and effect analysis is the other quality tools we use for our medical product. The concept is the same as what we do for the design failure mode and effect analysis. Our test plan will base on customers' specification requirements, including the functionality test, performance test, transportation test, all the way to reliability test and environmental test. Besides of these test items, we also have experience on the whole test, ALT test, acoustic, airflow, and altitude test for our customer to choose. If customer have specific test items, we have the flexibility and welcome this kind of requirement to discuss with our customer and also add these requirements into our test plan as well. Power quality analysis. Power quality is very important for the overall system's stability and reliability. We will measure all of the DC power sources on the board, and here is a list of our power analysis items. Our power measurement reports have clear information from the test equipment we use for the measurement, and all the detailed measurement reload of all of the power sources. And we also will measure the key components' thermal temperature to make sure all of the key components running within the specification. Highspeed IO interface analysis. Highspeed IO interface signal integrity is critical to systems performance and compatibility. At Avalue, we have both Tektronix and the Keysight's high-speed oscilloscope, can measure all of the high-speed interfaces like Ethernet, USB, SATA, PCIe, HDMI, and DisplayPort. For the PCIe interfaces, we can measure up to PCIe Gen 4. That means our scope can measure up to 16 bits per second, this kind of high-speed signals. Here is an overview of our in-house test equipment and instrument. We have several programmable temperature and humidity chambers. One of them, equipped with liquid nitrogen, can conduct thermal shock test. And we also have drop test for packaging test, vibration test, and EMI shielding room and ESD chamber and gun, as I mentioned in the previous page. Manufacturing site and capability. Avalue has two manufacturing sites. One is Leader Factory. The other one is Everson Factory. Both of them are ISO 13485 certified manufacturing sites, and both of them are also certified by the well-known medical device companies. Both of them are located in Taiwan. For the manufacturing capacity, our Leader Factory can produce 5,000 boards per month and 2,000 sets system per month. In our Everson Factory, there are 5 SMT lines and 2 dip lines, and also 3 system assembly lines. For the board level production capacity is up to 42,000 pieces and 4,000 sets for system product per month. Here is our production process flowchart and control plan. Each of our medical products have its own dedicated production process flowchart and control plan. For the medical product, we will conduct 100% AOI inspection after the SMT process. We will have 100% functionality test in the board level, and for the system level, we will have 100% run-in test at room temperature for 4 hours, and also 100% functionality test. During the production process, we have in-process quality control, and we have final quality check before we ship the products. Quality notice mechanism in production process. During the production process, if there are 3 continuous defects found in the production line, then the line manager will stop the manufacturing process immediately to inform our PM, QA, QC, and PE team to hold a quality issue meeting. Then issue a corrective action request for the issue analysis and the problem solving. Once we figure out the issue, and we will issue the engineering change request or change the production process. The corrective action report is based on AD root cause analysis methodology. And for the root cause investigation, we will focus on the 6 different aspects from the man, machine, material, method, measurement, and environment. Once the lesson learned, we will update our design file, validation process, and SOP accordingly to continue to improve our design quality. This is a summary for this presentation. At Avalue, we have more than 300 DMS service experience in both board and system level, and more than 50 projects for medical-related products. And we have specific NPI process with clear role and responsibility defined. And we use Oracle PLM system as our central control project management system. And we continue to do our design improvement. And DFMEA and PFMEA are 2 quality tools we use for medical-grade solutions to eliminate the potential failures and reduce the effects. Design quality validation includes signal integrity analysis, functionality test, all the way to transportation evaluation. Our 2 factories are ISO 13485 certified and also certified by the well-known medical equipment companies. In the past 20 years, we have lots of successful projects and products with key medical device companies. Last but not least, Avalue is Tier 1 medical equipment companies' proven DMS service partner. This is all my presentation. Thank you for your listening. We are looking forward to cooperating with you in the near future. Thank you.